Namaskar. Welcome to the final day of 1 week online International Faculty Development Program on Machine Learning and Computer Vision Application Research Challenges MLCV 2020, organized by the Department of Computer Science and Engineering of NIT Silchar under Techno 3 as training activity with Guwahati University Institute of Science and Technology, Assam. Good morning to one and all present here in virtual mode. Today, we have two eminent speakers, Dr. Tripti Goel from NIT Silchar and Dr. Ting Shoye from Multimedia University of Malaysia. Moving on towards our first lecture of Day 5, MLCV 2020, it is my privilege to introduce Dr. Tripti Goel. Dr. Tripti Goel is currently working as an assistant professor at NIT Silchar. She obtained her Bachelor of Engineering with honors from Mahorshi Dayanand University, Haryana, MTech from Shuttaram State College of Engineering, Haryana, and PhD from BPS Mahila Vishwavidyalaya, Haryana. She joined at NIT Delhi as an assistant professor in July 2015. After that, she joined National Brain Research Center, Gurugram, as a research scientist, where she worked on Indian brain template and quantification of biomarkers of Alzheimer's disease diagnosis. She is passionate about learning, teaching, and research in multidisciplinary domains involving neuroimaging, medical imaging, image processing, optimization algorithm, machine learning, and deep learning. Now, may I request you, madam, to kindly start your presentation.
Thank you, ma'am. Thank you for this nice introduction. A very good morning to all of you. Now I'm starting my presentation and just sharing my screen. So this is visible to all of you?
Yes, madam, it is visible. Yes, ma'am.
Okay. The topic of my presentation is the predictive biomarkers of the Alzheimer disease. Biomarker is an indicator of cellular or biochemical alteration or abnormalities that can be used to examine and diagnosis of the particular disease. Clinicians, scientists, healthcare professionals use biomarkers as a measure of person's health condition. So in this presentation, we will look at the useful Alzheimer biomarkers which can diagnose the disease at very early stage. So first is the introduction of the dementia. Dementia is a syndrome which results in decline in memory, perception, reasoning, attention, concentration, language, judgment, and thinking ability of the person. Worldwide, around 50 million people have dementia, and there are nearly 10 million new cases every year for the dementia. Dementia is one of the major causes of disability and dependency among older people worldwide. It affects memory, thinking, orientation, calculations, learning capacity, and judgment. People currently living with the dementia have not received a formal diagnosis. One study suggests that only 90% of the dementia people in India remain undiagnosed. Next is the Alzheimer. Alzheimer is the most common feature or form of the dementia. It is a group of disorder that impairs mental functioning. It causes continuous decline in thinking, behavior, and social skills. Alzheimer accounts for more than 60% of all forms of dementia. Alzheimer is the result of loss of neurons and their connections. These changes affect the person's ability to remember and think. Each 7 seconds, one Alzheimer case is being added in the world. In the United States, one new AD case is being added in every 68 seconds, and this number will be 33 seconds in 2050. Alzheimer's disease was discovered in 1906 by Dr. Alois Alzheimer. based on his observation and treatment of a 51-year-old patient, Miss Augusta. When Miss Augusta died, Dr. Alzheimer conducted the autopsy of her brain and described the morphological and the histological changes in the brain. Memory loss is one of the earliest symptoms, along with the gradual decline of the other intellectual and thinking abilities, called the cognitive functions. Causes of the Alzheimer. Scientists don't yet fully understand the causes of Alzheimer disease in most of the people. The causes probably include a combination of the age-related changes in the brain, along with the genetic, environmental, and lifestyle factors. The age-related changes include shrinking of certain parts of the brain, production of unstable molecules called free radicals, and breakdown of energy production within the cell. Some cases of early Alzheimer disease are caused by gene mutation that can be passed from parent to child. This can result in the early onset of Alzheimer disease. Also, the lifestyle factors can include the result of the Alzheimer disease, such as the dietary habits, high blood pressure, high cholesterol, which may influence the risk of the Alzheimer disease. This slide shows the progression of the Alzheimer disease from mild to the severe stage. In the single stage, in the first initial stage, there is the symptoms of the memory loss, language problem, mood swing, personality changes, and decline in the ability of the judgment. In the second stage or moderate stage, it may result into the behavioral personality changes, unable to learn or recall new information, long-term memory loss, wandering, agitations, aggression, confusion, or they may feel some difficulties in their daily activities. And in the severe cases, it may lead to difficulty with the walking, incontinence, or motor disturbance. So, role of the neuroimaging in Alzheimer disease. Neuroimaging is the non-invasive, non-contact technique of the brain, which enables a measurement of the various structural and functional biomarkers of the Alzheimer disease. So, we have three categories of the neuroimaging for the diagnosis of Alzheimer. First category is the anatomical brain imaging, which includes MRI, magnetic resonance imaging, SWI, susceptibility weighted imaging, QSM, quantitative susceptibility imaging. Next category includes functional brain imaging, which includes SPECT, single photon emission, computed tomography, PET imaging, positron emission tomography. And next category include brain chemistry measurement, which includes MRS, magnetic resonance spectroscopy. So we will discuss each and every neuroimaging in detail in the next slides. So first is the basic of the MRI. MRI is one of the biggest milestones achieved in the field of medical imaging, which provides high spatial resolution, soft tissue contrast. It uses magnetism, radio waves, and computer to produce the image of the body structure. MRI is based on the principle of NMR, that is nuclear magnetic resonance. So our human body is made up of 80% of water, which consists of hydrogen atom. This hydrogen atom has one proton in nucleus, which rotate around its axis. Usually, all protons are randomly oriented, as shown in this slide. On the left-hand side, all protons are randomly oriented, but after the application of the magnetic field, after the application of the magnetic field, the hydrogen protons tries to align in the direction of the magnetic field, as shown in this figure. Proton spinning around its axis, and this alignment of the proton due to the applied external magnetic field leads to the induction of a magnetic dipole moment in the direction of the magnetic field. The position of the magnetic moment of spin on its precessional path at any moment is called the phase. When RF phase is applied, the proton absorbs the energy and promotes it to the higher energy state. This absorption is called resonance, because the frequency of the applied radiation and the precession will resonate. This slide shows the image of a MRI scanner. Main component of a scanner is the magnetic field coil, gradient coils, and the radio frequency coils. Static magnetic field coils generate a high magnetic field. Gradient coils used to produce deliberate variation in the main magnetic field. Images generated through MRI are generally in the form of slices. Slices are the individual image which are stacked upon each other to form a complete 3D image. Slices are generated with the help of the gradient coils. Next is the RF coil. RF coil acts as a transmitter and receiver. After some time, RF pulse is removed and proton tends to return to their original state. During their transition, energy is released and received signal is then processed to generate the image. And based on the time required for proton relaxation, two types of MRI images are generated. These are the T1 and T2. T1 or spin lattice relaxation is a process through which net magnetization returns to its maximum value. The images related to the T1 relaxation is called T1 weighted images. T2 decay is a process by which transverse component of the magnetization decay or dephase. Images generated through the T2 relaxation is called T2 weighted images. So this slide shows the images generated through the T1 relaxation and T2 relaxation. So in T1 weighted images, fat portion is bright and fluid portion is dark. And in case of the T2 weighted images, fat portion is bright and fluid portion is dark. So T1 weighted images are used for the anatomical analysis and T2 weighted images are used for the pathological analysis. This graph shows the relaxation curve for the T1 relaxation and T2 relaxation. This slide shows the basic of the MRI pulse sequence. This is our RF pulse sequence. First sequence is the spin echo process, which is used to generate the T1 weighted image. It consists of 90-degree and 180-degree pulses. 90-degree pulse is called excitatory pulse and 180-degree pulse is called the rephasing pulse. When we turn on 90-degree pulse, proton align on the transfer magnetic direction, and then we turn off 90-degree, then 180-degree. Pulse is sent and it starts dephasing. Then we turn off 180-degree pulse, our proton release energy, which is captured by the RF coil to generate the image. Next echo sequence is the gradient echo. The gradient echo is characterized by a single excitation whose angle is less than 90-degree and then followed by an applied gradient along the axis, which will result in the dephasing of the gradient. So the image generated by using gradient echo is the T2 weighted images. This slide shows a structural block diagram of the MRI. So in this case, we have magnetic shield room in which we have MRI scanner. MRI scanner consists of three components: magnet, gradient, and RF coils. So gradient pulses are applied by the computer. Accordingly, slices are taken. These slices, the energy released by the body tissue will be detected by the RF receiver coil, which is given to the RF detector. RF detector converts that into the digital form and then it is fed to the computer to generate the MRI image. So next is the predictive biomarkers for the Alzheimer disease. There are mainly 5 biomarkers which are related to the Alzheimer disease. These are the brain structural alteration in Alzheimer disease, iron deposition, brain metabolites, glucose metabolism in the brain, amyloid plaque deposition. So we will discuss each and every biomarker in detail. These are the psychometric tests for clinical diagnosis of Alzheimer disease, which includes mini mental score examination, MMSE, whose scale is in between 0 to 30, clock drawing test, CDT, whose scale factor is in between 0 to 10, Alzheimer disease assessment scale, clinical dementia rating, global dementia scale, neuropsychological test battery. Mainly we use MMSE and CDT test for the psychological test of the Alzheimer disease. So if the rating of these tests is more, then the clinician will recommend any neuroimaging technique for the further consultation. So this is the first biomarker for the diagnosis of the Alzheimer disease. This is a coronal slice of the MRI image, which shows the anatomical changes in the brain as the progression of the Alzheimer disease. So this slide explains the atrophy of the brain. Brain atrophy is characterized by the shrinkage of the cerebral cortex. So as we can see in this figure, this is the brain of the common control normal patient, and this is the brain of the Alzheimer patient. So this cerebral cortex will shrink in case of the Alzheimer as compared to the normal patient. And in case of the MCI is mild cognitive impairment. This is the first stage of the Alzheimer disease. So the atrophy or the shrinkage of this cerebral cortical is in between control and the Alzheimer patient. So this is called the brain atrophy. Shrinkage of the cerebral cortex is called the brain atrophy. Brain atrophy is characterized by the shrinkage of the cerebral cortex. Brain atrophy is a common feature of Alzheimer disease. High resolution structural MRI can assess atrophy of the brain areas such as hippocampus, amygdala, caudate nucleus, putamen, cerebellum, nucleus accumbens, and body of the lateral ventricle and the temporal horn of the lateral ventricle. So these are the coronal sections of the brain which are related to the changes in the brain atrophy during the progression of the Alzheimer disease. So if we diagnose it or if we can recognize it at the early stage of the Alzheimer disease, a particular care can be taken for that patient so that its progression can be slowed down or can be delayed. Next biomarker is the brain iron. So role of the brain iron in the biological process, transport of the oxygen, regulation of the protein expression, cell growth, neurotransmitter synthesis, and electron transfer. So all these are the functions performed by the iron in the brain. But the increase in the iron deposit in different areas of the brain is observed in Alzheimer disease patient. Abnormal iron metabolism generates hydroxyl radicals, which triggers the oxidative stress reaction, damages cell repeats, proteins, and DNA structures and functions, and ultimately leads to the cell death. There is an imbalance in iron equilibrium in the Alzheimer disease. Excessive iron contributes to the deposition of beta amyloid and formation of neurofibrillary tangles, which promotes the development of Alzheimer disease. So because of the excessive accumulation of iron, we can have this type of dementia, Alzheimer disease, Parkinson disease, multiple sclerosis, depression, degenerative cerebral, intracranial hemorrhage. So to quantify the iron, we may have different imaging techniques. These are the MRI imaging. Second is the susceptibility weighted imaging. Next is the quantitative susceptibility mapping. So it is diagnosed that 1 microgram of iron per gram in the blood tissue is equal to the 1.1 part per billion of the susceptibility. So to quantify or to recognize the accumulation of the iron, first imaging technique is the susceptibility weighted imaging. So susceptibility weighted imaging is the combination of the phase image and the magnitude image. So our T1 weighted image is the magnitude image. Phase image is the using only the phase information of the body tissues. So in mostly cases, we consider only the magnitude image T1 weighted or either T2 weighted. We always ignore the phase image. So if we consider phase image consider more information than the magnitude data. So we can get more information for the internal parts of the body. So susceptibility weighted image exploits the magnetic susceptibility differences of the various compounds, including deoxygenated blood production, iron, and calcium. And thus it enables a new source of contrast in magnetic resonance. So SWI uses tissue magnetic susceptibility difference to generate a unique contrast. So we have a case-based data. Case-based data means we have the data which are captured by the RF detector. So it will generate magnitude image as well as phase image. So this phase image is first filtered by using homomorphic high-pass filter to remove the background noise. Then we extract the phase mask from this high-pass filtered phase image. Then this phase mask is combined with the magnitude image to generate the SWI susceptibility weighted image, magnitude image, and then after the minimal intensity projection, we will get our SWI image. So in SWI image, bright part in the phase image represent the dimagnetic components, for example, calcium, and dark part in the phase image represent paramagnetic components like iron or deoxygenated blood. So SWI is based on a fully velocity compensated high resolution 3-dimensional gradient echo sequence using magnitude and phase images either separately or in combination of each other to characterize the brain tissue. Next imaging modality is the QSM, quantitative susceptibility imaging mapping. So it is same as the susceptibility weighted imaging, but it gives a quantification of the susceptibility in their image. So this is the concept which is based on the magnetization. So magnetization induced in the body is equal to the susceptibility into the magnetization which is applied in the body. So this GI term represents the susceptibility, and based on this, we have generated the QSM images. This slide shows the processing of the SWI and QSM image. For acquisition of the QSM image, we use multi-echo gradient echo sequence. So first thing is remove the offset. In this case, as we are using multi-echo sequence, so we have to remove the offset from each and every coil. After that, we will combine all the images. Then phase unwrapping is done to remove the effect of the aliasing. After that, next step is the background field remover that remove the background noises, and then susceptibility inversion to generate the QSM image. In case of the susceptibility weighted imaging, we have the magnitude image as well as the phase image. This phase image and the magnitude image will be combined, and then after we will get our susceptibility weighted images. So this slide shows the framework of the quantitative susceptibility mapping image. So in this case, we will acquire two images, magnitude image as well as phase image. So first we unwrap phase image to remove the effect of aliasing. After that, background noise will be removed. From the magnitude image, we will extract the mask, and this mask and the background removed phase image are combined by using HEIDI inversion to get the susceptibility maps. So in the susceptibility maps, the darker part represent the iron quantification and the lighter part represent the calcium deposition. This slide shows the various brain parts where we can recognize the increase in the value of susceptibility for the Alzheimer disease patient. So it shows the value of susceptibility in cortex nucleus, putamen, globus pallidus, and the thalamus part of the brain. So all figures, we can see that the value of susceptibility is higher in case of Alzheimer disease patient as compared to control. And for the case of vascular dementia, it is a vascular dementia which is a stage in between the control and the Alzheimer. So this value is in between the control patient and the Alzheimer patients. So in this way, we can diagnose the iron deposition which is related to the Alzheimer. This slide shows the structural MRI images for different neuroimaging techniques. First one is a T1 weighted image, that is the magnitude image. Second is GRE image, it is your T2 image. Then is the SWI image, which is the phase which is a combination of the phase image and the magnitude image. And next is the QSM image, which consists of the phase image. Next neuroimaging technique is the magnetic resonance spectroscopy. Magnetic resonance spectroscopy is a neuroimaging technique that produces reliable and reproducible quantitative in vivo data on brain neurochemistry. It is also based on the principle of nuclear magnetic resonance. MRS reports the chemical shift in the nuclei in a given region of interest of the brain. In MRS, a small volume of tissue is excited in magnetic field and free induction decay is recorded to produce a MR spectrum. The area under each NMR peak corresponds to the concentration of that particular metabolite. So as we can see from these two figures, first figure on the left hand side is the control and second is for the Alzheimer. So the ratio of the NAA chemical and CR chemical is higher in control as compared to the Alzheimer patient, and the ratio of the ML and CR is higher in case of the control as compared to the Alzheimer patient. So by calculating the ratio between different chemicals, we can diagnose or we can predict the biomarkers for the Alzheimer and MCI patient. Next neuroimaging technique is the positron emission tomography. Positron emission tomography is based on the principle of radioactivity. A radioisotope is injected into the patient which emits gamma radiation as it decays. And these gamma radiations are collected by gamma rays detector and processed by computer to produce the image. So PET imaging provides information about the pathophysiological and biochemical conditions of the brain. So this slide shows the amyloid imaging of the PET. Amyloid plaque deposition is the major cause of the Alzheimer disease. Amyloid imaging with PET has the higher specificity than the MRI imaging. For amyloid imaging, 11C-PIB radio tracer is used to account the deposition of the amyloid plaques in the brain. So, as we can see from this figure, amyloid plaque deposition is lower in normal control as compared to the MCI and compared with the AD. So, as progression of the disease increases, accumulation of the amyloid plaque also increases. So this neuroimaging technique can also be used as a predictive biomarker for the Alzheimer disease. Next is the effect of the glucose on the human brain due to the Alzheimer. As we know, human brain consumes 20% of the body's total energy requirement. Glucose is the main source of energy for brain due to the higher blood-brain barrier permeability. So using F18FDG radioisotope, it was found that glucose metabolism was impaired in the brain of the AD patients. So images shows the brain regions that are affected by AD have the lower glucose metabolism in the cortical region. So first row shows the glucose metabolism for the normal patient, and as we go down, it shows the glucose metabolism as the progression of the Alzheimer disease. So the last row, row number D, is for the Alzheimer disease patient. So here we can show that there is less accumulation of the glucose in the Alzheimer disease patient. Next slide shows the deep learning methods for medical image synthesis. So for the case of Alzheimer, it consists of total 4 steps. First one is the brain registration. As we know, different images are captured from different machines. It may be Philips, Siemens or GE scanners. So all the images, all the machines have different configuration, different number of slices, different time recovery, echo sequence. So for automatic diagnosis of the Alzheimer disease through the deep learning network, we need the registration. Registration means we have to fix the dimension of all the images. Second is the segmentation. For the structural MRI, hippocampus is the main thing which consists of the biomarker for Alzheimer. So if we segment hippocampus from the complete MRI, then our calculation or complexity of the network will decrease. Next is a computer-aided diagnosis. It consists of the diagnosis or classification of the image in normal, Alzheimer, or MCI patient. Next technique is the image synthesis. It is to generate the different images or number of images from a MRI images. So next is the concept of the neural networks. So all we know the neural networks. The basic unit in machine learning is the neural network. Neural networks are the parallel computing device which basically attempts to make a computer model of a brain. They mimic a neural signal firing structure of brain using computational processing unit. Basic unit of the neural network is a neuron, which consists of dendrites, cell body, and axon. In our brain, there are approximately 10 raised to power 11 neurons with a total interconnection of 10 raised to power 15. Main parts of the neurons are dendrites, cell body, and axon. Dendrites are tree-like structures responsible for receiving the information from other neurons. Cell body process the information which they have received from the dendrites. Axon is a cable through which neurons send the information, and synapses is the connection between axon and other dendrites. So this is the neural model transformed into the neural network. This slide shows the mathematical model of the neural network, which consists of n number of inputs. Then we have a cell body which processes these inputs, and activation function which converts this function into nonlinear space, and then finally output. This is the flow diagram for the conventional neural network. First step in this is a data equalization. Data equalization by using CT scan, PET imaging, or MRI, MRS, whatever be the source of the data. Next is the data normalization. Data normalization consists of the noise removal, data registration, segmentation, or any pre-processing technique. Then is the feature extractions. Feature extraction is the is to extract some useful features from the image so that it can reduce the space required by the complete data. And it is very useful step in any classification process. Mostly this work can be done by the doctor, which label the image. Next step is the classification. In conventional neural network, we use logistic regression, sport vector machine, nearest neighbors, decision tree, etc. to classify the image into a particular class. This slide shows the difference between the machine learning and the deep learning network. So in machine learning, we have first data normalization, then feature extraction, and then classification. But in case of deep learning, we have input, and then we have a complex layers which consists of the convolutional layer and pooling layer, which automatically normalize the image as well as extract the high level features and then classify the input image into a particular class. So this is the main difference between the machine learning and deep learning. That's why most of the recent research are doing in the field of the deep learning. Also, the accuracy and the performance metrics of the deep learning is far more better than the conventional machine learning methods. These are the basic building blocks of a typical deep learning network. So first we have an input image. Next we have the convolutional layer. Convolution layer is the heart of any deep learning network, which extracts the high level features from the image. Next is the pooling layer. Pooling layer reduces the size of the convolutional layer by using two methods, whether it is max pooling or average pooling. So deep learning network consists of a number of convolutional layer and pooling layer to extract the high level features. Then at last we have the fully connected layer. So the after convolution layer, all the filter are converted into a vector form, and then it is connected using fully connected layer. After that, whether we can use either we can use sigmoid function or softmax function to classify the input image into a particular category. This is the workflow representation of deep learning for Alzheimer classification. So in case we have input image, in this figure I have shown MRI image. It can be your PET image, MRS image, or CT scan. So first step is in this pre-processing. Pre-processing means we have to remove the noise, registration, and if we want to segment hippocampus or any other parts, then we can segment it. Then we have to divide the complete data into 3 categories: train data, validation data, and test data. Train data is used to train the deep learning network. Validation data is used to validate our trained network. Then is the test data. Test data is used to find out the accuracy of the network. So this data will be fed into the deep learning model. Nowadays, various pre-trained deep learning models are available. These are ResNet, AlexNet, MobileNet, SpaceNet, PGG, InceptionNet. So we can use either of any of the deep learning network for training on the Alzheimer and MCI patient. And after the deep learning training, we will get our result into a particular category, whether it is Alzheimer, control, or MCI patient. So this is a conclusion. Alzheimer disease can diagnose the disease in its preclinical stage and can be used to assess treatment efficiency, which is urgently needed, because if we diagnose the Alzheimer in the previous stage or initial stage, we can take care of the patient by using certain medications or by changing the lifestyles. So it will slow down the progression of the Alzheimer disease. MRI has a potential to identify cortical regions of abnormality known to be affected in Alzheimer disease nearly a decade before clinical symptoms of the dementia emerged, providing important preclinical evidence of neurodegeneration. So by looking at the imaging biomarker, we can diagnose the Alzheimer disease at least 10 years before. So it will give higher specificity and sensitivity as compared to the clinical symptoms. New guidelines for diagnosis of AD set by joint NIA, National Institute of Aging, panel of lead scientists recommend the assessment of dementia due to AD, dementia due to MCI, pathology for AD autopsy, and need for the biomarker development for the preclinical AD. In 2011, it was named that hippocampal atrophy decreased 18 FDG PET imaging and increased A beta PET as the 3 of the 5 AD biomarkers recommended for the use in AD diagnosis and clinical research. Also, the hippocampal volume measurement by using structural MRI or even weighted image for the patient can also enrich the clinical trials for the prodromal AD and MCI cases. So that's all with the Alzheimer disease, biomarkers for the Alzheimer disease. Thank you. So if any person is interested in doing PhD or internship in this area, so these are my contact details. You can mail me or you can go to my site's webpage and you can contact me. Okay,
Thank you. Thank you very much, madam, for sharing your deep knowledge with us. Your session was full of enthusiasm and valuable knowledge. Madam, we have some questions from the participants. So now I would like to start the questions.
Okay, ma'am.
Ma'am, may I request you to kindly stop presenting so that I can put forward questions from the participants.
Yes, ma'am.
Madam, is it visible?
Yes, ma'am, it is visible.
Okay.
How chemotherapy works in brain tumor case? Actually, I am considering here only Alzheimer disease, not a tumor case. So chemotherapy is the clinical process that is used to cure the tumor, not for the Alzheimer disease. So Alzheimer disease can't be cured. It is a progressive disease. We can slow down the effect of the Alzheimer disease, but we can't use any type of therapy, chemotherapy, for the cure of the Alzheimer. But changes occur in lateral ventricles in case of the Alzheimer disease. So there will be the shrinkage in the lateral ventricles, and which is termed as the atrophy. So 40% of the Alzheimer patient will have the ventricle atrophy, and we can measure it by using our quantitative measurements to amount for the ventricle shrinkage. This segmentation technique can give better result in case of the MRI diagnosis. So various tools are already available on net. It is FreeSurfer, FSL, and the SPM12. So either we can use all these tools to segment the MRI image, or we can use our mathematical or neural networks like threshold, region growing techniques, or fuzzy clustering techniques for the segmentation. And we can compare the result also, which segmentation technique is best for the MRI diagnosis, for the AD diagnosis. Do biomarkers enhance the diagnostic accuracy? Yeah, biomarkers enhance the diagnostic accuracy. And if we can use multimodality biomarkers, for example, if we use MRI as well as SWI, QSM, as well as PET imaging, then it will also improve the accuracy of the diagnostic. Which deep learning network can be used for dementia classification? You can use any network. You can train your own convolutional neural network also. You can use ResNet, AlexNet, VGGNet, InceptionNet. So whatever the deep learning networks are available, you can use any of the network. Can K-means clustering used for mapping and diagnosis of the MRI images? K-means clustering can be used for the segmentation of the image, MRI image. It can't be used for the diagnosis purpose. Are the neurons of the brain associated with deep learning or machine learning? Neurons of the brain are associated with both deep learning as well as machine learning. So deep learning is just the advanced version of the machine learning. So machine learning, it takes the brain map of the human, and deep learning, it takes the brain mapping of the cat. So both are related to the neurons of the brain. What is the influence of the activation and fitness function in research? So, ma'am, in previous slide.
Okay, madam. What is the influence
of the activation? Look,
yes.
After the processing of the inputs, means after the output of the hidden neurons, it may happen the output may be negative, may goes to infinite, minus infinite, or plus infinite. But we have to limit our output of the neurons into a specified value. That's why we use the activation function. For example, in deep learning, we use ReLU function, whose value is specified in between 0 and maximum. So it can't go to negative value, and the positive value will remain the same. So to get the efficient output, we use the activation function. Ma'am, next slide.
Yes, ma'am.
With CNN architecture, give good accuracy for MRI image. That you have to check. You have to do experiments on different CNN structure, or you can use pre-trained model also. So you just train the model, classify the data set into training and test set, and just check the accuracy performance metrics. After checking, you can get your result. So it depends on the application, depends on the data set which you have used, whether you have used MRI image or PET image. So it is not specific that any CNN architecture or any deep learning network will give accuracy for each and every application. So for that, we have to check for each and every application. PET imaging or MRI, which one is best for SD diagnosis? Actually, PET imaging is the best for the ED classification, but the main problem with the PET imaging is the radio tracer. It consists of the radio tracer, so it may be harmful for the high exposure of the radio, this gamma rays may be very harmful for the patient, especially for the pregnant ladies or patient which has some diabetic patient. So in most of the cases, we do not recommend PET imaging. We use MRI imaging for diagnosis purpose, because MRI images uses radio waves which are not harmful for anyone. What are the free learning resources for the deep learning? You can use MATLAB free learning source. You can go to the MATLAB in help documentation. So complete courses there. You can learn deep learning from there. What are the prerequisite knowledge required for learning the deep learning? First thing is the mathematics. Second is the neural networks. So without mathematics, you can't go understand the concept of the deep learning. So that's all with the questions. Ma'am, any other question?
Yes, ma'am. Just a minute. I'm taking from the YouTube, ma'am. Is it visible, ma'am?
Yes, ma'am. What can be the specific research area in predictive biomarkers? Can you suggest specific data set that is available? Okay, if you know about available data set, tools, and programming language, you can mail me. Just mail me, then I will give the information about the tools, database, and whatever the programming language you want to learn. What is supposed to be the safest medical imaging platform with the applied deep learning algorithm? So, accordingly, I think MRI imaging is the safest because it contains radio waves, and radio waves are not harmful for the body. So MRI is the safest imaging technique. Ma'am, any other question?
Yes, ma'am. Yes, ma'am. Just I'm copying from the YouTube, madam. Just a minute, madam.
Minimum intensity projection is not displayed. It is just a projection, nothing else. Means we have to improve the resolution of the susceptibility weighted image. Look, MRI image consists of only magnitudes. So the resolution of the magnetic resonance imaging is very good. But SWI image and QSM image only contains the phase, and phase contains lot of noise. So for improve the resolution of the SWI of phase information, we just do the projection to improve the contrast. It is nothing else. Can you please tell how drug for repurposing is helpful to find new drug in CNS? Actually, my work is not to deal with the drug, only for the diagnosis purpose or predicting the biomarkers. There any research using it? Yeah, using EEG also you can diagnose Alzheimer disease. But my presentation consists only of the neuroimaging data. So I consider only the neuroimaging data. You can use EEG signals also and MEG signals also. So a lot of research are going on EEG signals as well as MEG signals for the diagnosis of the Alzheimer.
Okay, ma'am. Thank you, madam.
Thank you, ma'am, for inviting me. Thank you so much.
Thank you, ma'am. Just I want to say once again, thank you for your informative session. It was very helpful and it is very interactive, madam. It was very knowledgeable session. Thank you so much, madam. Thank you,
ma'am. Thank you so much.
Thank you. Thank you. Participants, before moving to our next session, let's enjoy a video of NIT Silchar. Professor Ting, sir?
Hello, hello. Good afternoon.
Professor,
good afternoon, yeah.
welcome, sir.
Thank
welcome,
you,
sir.
thank you. Yeah, thank you.
Sir, namaskar.
No worries, no worries. Okay, no problem.
Thank you, sir. Thank you.
Thank you.
Yes, sir. Welcome back to the final session of MLCV 2020. Now let us have the pleasure of listening to the honorable and great speaker, Dr. Ting Sho Yi, Multimedia University from Malaysia. Dr. Sho Yi Ting is currently working as Associate Professor at the Faculty of Computing and Informatics, Multimedia University, Malaysia. He is also the Deputy Dean of the Institute of Postgraduate Studies, Multimedia University. In the year 2002, Dr. Ting was awarded the Fellow of Microsoft Research by Microsoft Research Asia, Beijing, China. He has been active in research projects related to predictive analytics and big data. Most of the projects were funded by MOE, MOSTI, Telkom Malaysia, NDEC, and industries. In the year 2014, he and his team members won 2 national-level big data analytics competitions. Dr. Ting has been the trainer for MTEC and intern for courses related to big data and data science. He is also the consultant, mentor, and assessor for the project under MTEC funding. Currently, he is working on trouble ticket resolution prediction for Telkom Malaysia, AirAsia seat capacity optimization, dengue outbreak prediction for the government of Philippines. Dr. Ting is certified in Microsoft Technology Associate, IBM DB2, CDA, and COSE Data Science Specializations. Now, may I request you, sir, to kindly deliver your speech. Sir, kindly.
Okay, thank you very much to the chairperson and Dr. Naresh. Thank you for inviting me for the knowledge sharing for this session. I would like to share a bit of my knowledge on location analytics, how we use analytics for location-related businesses. Allow me to share my screen now. Okay, so let's proceed with this. The title of the speech today is actually location analytics and its use cases. I welcome all the questions if you have, and I do my best to share whatever I know within this domain. Now, I've been working in location analytics for almost 6 years. 6 years, and most of the funding, research fundings, were actually supported by Telekom Malaysia. So based on the experience that I got, I would like to share through this knowledge sharing session. Okay, now let's define what location analytics is. Location analytics extracts additional insights from business data by adding a layer of geolocation information. Usually, it is used for transactional data such as sales, logistics, and supply chains to allow a new dimension that help contextualize specific figures. I got this text here from Census 2020. So this is what location analytics is about. In location analytics, we actually gather a lot of data to support business, basically. Although there are many other domains that can leverage on location analytics, such as agriculture, or the initiative by the governments, right? So my experience with location analytics mainly on business related. Now, business cases via location analytics. Let's look at this in a very simple way, right? I can name it in 3. Number 1, why we need location analytics. We actually use location analytics in order to facilitate and to complement the existing GIS, that is Geographic Information System. So that is the main purpose of location analytics, that is to complement GIS. The second one is to facilitate the investors in expanding into other type of retail businesses, given a particular new location or given a set of new locations. So given a location, what is the best retail business that I can set up there? So that is a big question to many people, because as we know, investing in business costs a lot of money. If we do not plan it properly, if we do not take into considerations of many factors, then it will actually we are getting a loss. So that is why we should actually prevent, right, disaster happens by looking into a detailed profile of the locations and also how this location can be matched to a particular business. That's why that is what is the concern of the investors. The third one is actually to help the banks. As we all know, post-COVID or during COVID-19 era, we are actually suffering. Everybody is suffering. I believe that India is suffering. I believe that Malaysia is suffering, and many countries are suffering in terms of businesses. Now, how could the bank actually facilitate everyone, right, to regain the momentum in economy? So location analytics play some sort of important role to help the bank identify what would be a good business for that particular location. In this case, we actually minimize the loss for that particular retail business. So what would be the problem statements that we see in business? Number one, how could we actually optimize the win probability, the fitness score between a retail business and a given location of interest? Second, what are the features that we need when we do machine learning? We need sales, we need geographical or geospatial data, we need satellite images. So you can see that we are moving from conventional machine learning to deep learning, in addition to taking into considerations of images, image processing, right, and analytics. So we need all these different components of AI to get a good recommendation from the recommender systems. The third one here is, what would be the good machine learning techniques? As I mentioned just now, we take into consideration of conventional machine learning techniques. We use deep learning, right? We also go into image processing, whether we use deep learning or we use conventional machine learning techniques. But there are so many different types of deep learning configurations. There are so many types of conventional machine learning techniques. So which are those that fit into that particular domain? So that is a big question, because we cannot and we are not able to test every single technique, right? So that is also an issue to us. The next thing here that we faced during our project previously was that we could have a great system, prediction system, but to public, would it be useful? Would it be easy to deploy it in a smartphone, a handheld devices? We know that smartphone, whether you are using Samsung, Huawei, Apple iPhone, and so forth, they are basically do not have that big computational resources as compared to a conventional desktop or a workstation. So how could we actually have our system run smoothly in these resource constraints devices? How? That is a big question. That is something that the industries can look into. Now let's look into the solutioning, right? The solutioning here for GIS, right? Now, the conventional way of doing location analytics, the conventional way, the usual practice way of doing location analytics is via GIS. Well, what is GIS, by the way? GIS is actually trying to have layers of data on top of a map. So as you can see in this page, you can see if we want to make a particular recommendation, we are looking for some decision making here. We need different sort of data. We have different sources of data, but they are actually overlapping on the same piece of map, right? You have 4 layers of maps here. You have 4 layers of map. Each layer represents a data, some sort of data. So we call it data layer as well. So when you have different data layers on a map, then for human to visually look at the insight, so-called the insights, will be very difficult. Suppose that the lowest level is green in color, the second one is red in color, the third layer is yellow in color, the highest level is brown in color. What do you see towards the end? Of all these layers come together, you see a black color maybe. So that is not very useful to human being, because when different colors that overlap each other, then you see funny colors, right? And you actually covered the location information. You don't see the street, the name of the streets. You don't see the building. It's covered by the layers. So it's very difficult. Not that this technique is bad, but it's challenging to human to visually extract insights from GIS. Again, I'm not saying that GIS is not a good way to do location analytics, but it is a challenging for human to visually extract information and insights when you have many, many layers, one on top of another, right? So because of that, in our project, we try machine learning approach. We tried. It took us a few years to do this, right? Why we came up with this idea? Mainly because not only visually we relax on the visual inspection, we could actually allow the machine, or we push all the jobs to machine to crunch the data, crunch the data and find insights for us automatically without us to go inspect one by one. So it is a relaxation for us, for human being. So look at the first point here, the solutioning part. Actually, we try to transform the point of interest. Point of interest here refers to every single items, such as the shop, the places of religious, the school, the universities, everything, right? Geographical assets. These are called point of interest. And geospatial data. Geospatial data are data such as the population data, right? The population data. So these are the data that we assemble. These are the data that we gather to form an analytical data set. And this analytical data set is the only format that can be fed into machine learning models. For the second point here, in order to deal with satellite maps, satellite images, we use deep learning. No doubt, deep learning is one of the best techniques dealing with images. You can have so many types of configurations, right? The parameter tweaking in order to ensure the accuracy to gather insights from images. Now, in third point here, we try to actually use different types of machine learning techniques together with deep learning, and we do proximity reasoning as well in order to come out with an aggregated recommendation system. Now, is there any research elements in this location analytics work? It seems that it's very business tight. So what would be the research element here? The research element here is a lot. It's really a lot. How do you actually fuse different sources of data, and how do you identify them? How do you find the optimal features for a particular domain? In order to do prediction of cells, you need these features. In order to predict COVID-19, you use another set of features. If you want to predict on the setup of a clinic, you use different features. So this is something that is interesting in research. Do we have a common set of features among all different domains, or do we need different types of different types of features for every domain that we have? So this is one of the area that we can look into. Another area that we can look into is how do we actually ensemble the machine learning techniques, and what are the techniques, how to ensemble, how to actually aggregate them together. In addition to that, by ensembling doesn't mean that the accuracy will be much higher than applying a single classifier or a model. So what sort of parameters are we tweaking here? How do we actually change the hyperparameters? What are the considerations, right? So do we need to, can we use the existing out-of-the-box algorithms, or should we actually modify accordingly to fit the particular domain? These are some of the research, very interesting research domain to look into, and it's very interesting, as I said. Yeah. The third one is something that we are looking into. So we know that deep learning is superb for images, but would it be also useful for satellite images? What can we get from satellite images using deep learning? What do we want to train? It's not about the deep learning architecture itself. It's actually does the domain insight, does the domain insight can be actually extracted successfully via deep learning solution. So these are something that very, very important. As we have heard from the previous speaker, deep learning has been used in medical, in all the MRI, the scanning. Yes, is superb. No doubt it is superb. So in satellite images for location analytics, would it be having the same accuracy? That is something that we are actually looking at now. So this is the entire system architecture that we deployed for Telecom Malaysia and some other companies, right? This is a general architecture, but different companies will have different architecture. So we have to adapt. We must adapt as well. We must change. Now, suppose that the front end is existing GIS, right? You can have your own GIS system. You can use the existing commercialized products. Doesn't matter, as long as it allows integration, a connection to some API, and that API is linked, is exposing your business logic. You may not want to put your logic inside the GIS itself, because that would be a bit tough to modify, to migrate a lot of constraint. You might want to put it at you might want to externalize it, right? Usually business will externalize the business logic and expose it via some web services or API. So your business logic here is actually linked or integrated to the location analytics module. We don't link it directly to the API usually, because the when we do location analytics, the business logics is something that we refer to, right? We treat the business logic as the SME, subject matter experts. So it is where the business logics talk to our location analytics module rather than we connect directly to the API. So in the location analytics module, we have machine learning, which is conventional machine learning techniques, and we have deep learning, as I mentioned just now. Now, we also externalize, right? We also externalize all the geospatial data, all the data set that we have, and we don't couple it with the location analytics module. This is to ensure that the data can be actually manipulated without touching the location analytics algorithm, right? Decoupling everything is the best practices that I have actually experienced. So this is the overall architecture that we deploy for companies, including Telecom Malaysia. So an example of commercial engagement here that we experience, right? You have the user requirement, you have the component design, where the analytical data set, the machine learning, the deep learning comes in, right? And you have to fine tune the GIS and integration with it. And after that, you go for different packages or different plan to suit different set of clients. So this is also something that I experience. I do grateful and thankful to the industries for letting me experience all these commercial engagements for our location analytics products. So in terms of project wise, right, we run R&D project in this case. We study the current GIS architecture. That is the first thing that we study, because we need to know what GIS are you using, whether you are using your own developed products or you use a commercialized product. That is the first thing that we study, because in our very early experience, we develop the module first, and finally we go and study the GIS. So we found out that the GIS, during that time, 6 years ago, the GIS module was not able to talk to Python and R directly. So that cost us a few months just to modify the package, the module. So it took a lot effort to do that. So for us now, we actually study what GIS architecture you have, what software are you using for the front end. Then from there, we design our location analytics module to fit you rather than you fit us. Okay. Secondly is that we get all the POI data, point of interest data, the population information, satellite images. And number three, we actually we look at the data that we collect and also the business, the domain, and therefore, and from there, we actually identify what are the good machine learning techniques that could be potentially useful to solve the domain. In Python itself, there are more than 200 different packages. In R itself, I believe that there will be a few hundreds. So we cannot be getting all the 200, right, to test. It is impossible. Rather, we identify those that are good in the sense of meeting the requirement for that particular business domain, right? We from there, we scope down, we identify, and we tested. We were going to test, right? A few those that are shortlisted. And finally, that is where we do integration and model tuning. So in research work and in commercial project is a bit different. In research work, we can deploy as many types of we can do experiments with as many types of prediction model that we want. But in commercial setting, due to many constraints, many constraints, the auditor, right, auditing issue can be also a factor for you to determine what model that you can only use. So there are many factors actually when it comes to commercialization in terms of speed, in terms of storage, everything. So it's not in R&D whereby we can do anything we want, we can test everything we want under the sun. No, it's not the case in commercial project. Okay, let's zoom into a bit on how we construct the location analytics module, right? So what we did here was we actually started with constructing the analytical dataset. That is the first thing that we do. The second one is we get all the business data, right? And the third thing is we construct the predictive model. So that is the ecosystem for the location analytics module. Now, what we want to do and how does this analytical data set look like? It is basically transforming what you have in the data layers become a flat data set in a tabular format. That's all. That is a solution. Nothing more than that. So we are getting the data layers and put it in tabular format so that it has a flat format. As simple as that, right? So you can see that is a direct transformation. But what you have to remember here is that what we learn as well is that some of the data, they are transactional data. And actually, there are a lot originated from transactional. So how do we actually transform the transactional data into tabular format, right? So that it is a representation of a correct analytical data set. And it is a meaningful analytical data set for machine learning purpose. So let's go through a bit here. So the first thing here is to identify the source of point of interest data. So if you are interested to deploy location analytics solution or to try a bit on location analytic research, the first thing that is always a challenge is to look for the point of interest. Now, where can you get the point of interest data? For India, for any countries, you can just go to Yellow Pages. Yellow Pages provides tons of data. I'm not sure the accuracy, right? Different countries will come with different accuracy. It means that, okay, you go to Yellow Pages for a particular country, you type a particular shop. Yes, the shop exists in Yellow Pages, but does it exist down there on the street? And that is something that we may want to understand, that is accuracy. But one thing that you can be happy with is that Yellow Pages has a very good amount of data for you to start with for location analytics projects, right? The second, you have, as I put here, you have the Yellow Pages. In addition to that, you can go to some government website for your country, or you can go to some open data set, right, supported by your country, the government. Right? You try to find some so-called free resources that you can start with. Okay, so in this case here, I provided the sample using Yellow Pages. Now, let's to provide a better understanding of what we are doing and what location analytics is, allow me to use an example that is McDonald's. right? I'm not here. I'm declaring that I'm not a salesperson for McDonald's. All right, I'm just using this as an example, and I hope that McDonald's is also fine with it. Right? Suppose that in this example we use McDonald's as an illustration only, right? So the issue here is that where is the good location or locations for McDonald's to expand its business in India? So if I am the CEO, if I'm the CEO, I might have a KPI of for year 2021. My KPI here is to set up 500 new outlets in the whole India. So the question here is that 500 is not an issue. The issue is where should I put them? Where should I put them? Should I put them near your university? Should I put them somewhere in Chennai? But in Chennai is so big. Where? So where should I put it? Right? Because the renovation cost, because the transportation, the everything is money. So if I set up at a wrong location, well, that will be a disaster because I have already invested. If I put it at a good location, wow, that will be a good business for me. So that is why location analytics is crucial. The planning part is crucial. Okay. Now, how do we extract the point of interest in this case? Now, suppose that the red color in the middle with an X is McDonald's, right? Is the existing McDonald's. Okay. So what I do here is that I go and extract. Okay, this page here is telling me that the one in the middle, which with the X, the red color, is an existing McDonald's outlet. Is an existing, right? Okay. So what we need to do here is to extract all the shops within 100 meters from McDonald's. Existing McDonald's in India, say for example. Suppose that there are 1,000 McDonald's in India. In Malaysia, we have around 300 something McDonald's outlets. So what I need to do here is that I go and extract all the shops within 100 meters from the 300 outlets in Malaysia. Get that right? Okay. I get. Now, why 100 meter? We did a very simple survey in Malaysia. It might not be true in India because this is just a parameter. You can change, you can tweak. For Malaysian, anything more than 100 meter, we are unlikely to walk to. If the shop is 100 meter from my current position, if I can drive, I will drive. That is Malaysian, right? It might not be true for the entire Malaysian, but that was our experience when we asked around when we did our project last time. So Malaysian has a tolerance of 100 to 150 meters, right? Because we are also quite hot. Our weather here is hot and wet. So if it's raining too heavily, walking 100 meters away, you can get wet. So unlikely. That is why if we can drive, we will drive there. If it's 150 meters away. But it might not be correct from time to time. So we adjust this parameter from time to time. All right, we adjust the parameters. Okay, so that depends on the country, the culture. So in this case, just assume that 100 meters. This is for one outlet. So what we did here last time was that we actually go and extract, as I mentioned, 300 different outlets in Malaysia. Right. So location A, you see the setting of the business, the threat area is different. Location B, the threat area is different. Location C, the threat area is different. So what you are expecting here is that, hey, in location A, I am getting a bank in Citibank is there. Location B, hey, I don't see Citibank. In location C, hey, I get a Starbucks. So you see, different location, the what is surrounding McDonald's at different locations, you have different outlets, right? Different. So I give you an example here. Now for location A, you have 7-Eleven, Burger King, Citibank, Jumbo King, Ratna Cafe, Dashini. But in location B, you have Starbucks, right? But location A doesn't come with Starbucks. You have Plaza. Okay, in location C, you have Indian Coffee House, right? You have KFC, you have Citibank, and you see different. You get me or not? If you have 1,000 locations, the ABC will go down until 1,000. It is exhaustive. You get the entire list of them. So do you want to do it manually? No, you get the system to automatically extract the information. Okay. Now, the issue here is that by looking at these surrounding shops, location A, B, C, D, E are considerations of the differences, right? So the question now is that how do we identify that these are the anchors? These are the so-called characteristics that are actually crucial for McDonald's to consider when, right, when they want to set up a new outlet at that location. So that is what difficult for us. So we everything here, every single shop here, we call it a feature. Of course, that is feature. So what and how are we going to get the good features? So what we can do here is that we can use based on frequency. Based on frequency is very simple. Suppose that out of 1,000 locations, right, well, out of 1,000 existing McDonald's outlets in India, say for example, you see most of them, 500 out of 1,000 outlets, you see Starbucks. So can you conclude that Starbucks is somehow important, right? So these are, we call them as anchor. No? They are actually something that commonly appeared together. So frequency is something that we are looking at. We can also based on subjective evaluation. Now, suppose that in McDonald's, right? In McDonald's, say for example, Malaysia, say for example only, right? Suppose that okay, the chief marketing officer says that we observe that if the next door is a self-service laundry, listen carefully. If I am the expert, I'm the chief marketing officer, based on my 20 years of experiences, I will say that as long as there is a self-service laundry next to me, wow, that will be a good place to set up my outlet, the next outlet. So this is also based on subjective evaluation, right? Now, the third one is that we go by feature selection. That is the simplest way to do. Why feature selection? Because we do not want to fix to a particular method. We let the machine look for the features. Give me the top 10. Give me the top 20. Give me the top 50. And the good thing about that is that it can be adjusted automatically. It can be adjusted dynamically, right? So what is this feature selection doing? What is this feature selection doing? So this feature selection is important because of the large feature space. Now, what is these features and what are these features? These features are every single shop is a feature. McDonald's is a feature, KFC is a feature, Starbucks is a feature. Every single shop is a feature, right? And when you add up with weather information, traffic information, the geography features, then you can imagine that in addition to all the shops as a features, you have weather information, you have traffic information, you have population information, gender, the end up you have a huge feature space with 200 columns with 200 features. Suppose as an example. So it can be very large. It can be very large. So that is why if you use feature selection technique, right, you can actually minimize the human workload, give it automated way of extraction of information without you to monitor anything, right? The common feature selection methods are Boruta and RFE. Well, you can use whatever methods that you think comfortable with, right? No issue, go ahead. So we run feature selections to identify the correlations. So that is the first thing. We get the metrics. We also get the score, right? That is where we identify the final features list. And from the feature importance, we run the classifiers, right? The purpose is to identify the optimal feature set. So we want to know what is the good number of features, rather than arbitrary or simply identify the number of features. Give me top 5, top 10. Why top 10? Why top 5? Why top 15? So we run the entire feature space, run it using different classifiers, and we see where is the sweet spot for us to identify the optimal number of features. We also, as I mentioned just now, the feature analytics module can be very good for a computer, a desktop. But when you go for mobile devices, well, it kind to be very lagging, you see. So we also check on the time spent in constructing a particular model, into in doing prediction, real time, everything we check properly. So that that is for a commercial setting. So this is the final data set for the POI. So for every location, you have 01001 as a binary indicator of existence of that particular POI in that location. Once you have that, you do for the rest. You get population information, you get weather information, you get sales, you get the property, right? What sort of people living there, what is the salary like, and put it in a beautiful tabulate data. So for sales, you have to do a bit of the transformation, because it might come in transactional data set. So lastly, you can see that the sales is actually the sales is actually the target variable, while the rest are the independent variables. So in Python, if you are doing Python, you need to do label encoding or all sort of encoding. The common one, they are the label encoding and one-hot encoding. Of course, you need to do normalization and all sort of statistical tests before you push the data set into the machine learning, so that the performance is correct, right? Correct. So you can use different type of linear models. You can use tree-based, up to you, right? So as long as you identify what are the independent variables, target variables. Okay, let's give it this example here, right? An example here. Location analytics, we have done it for Telecom Malaysia, right? We have done it for a few companies as well. The recent one in March, I would like to thank the state government for giving me the opportunity to involve in the COVID-19 for the state level. What we did here is that we actually, together with the team, the IT team, the data science team, we actually construct location models as well, location prediction model as well, to identify what are the locations that are categorized as red zone, blue, yellow, green, and so forth, right? We also identify whether or not that location is similar to another location, so that if in the event that this location has an outbreak, immediately we might want to study, we might want to investigate on those highly similar locations, so that we call it active prevention can be conducted. By the output of our work was quite successful, right? We actually the government was so supportive with our finding. They actually ran the mass testing campaign, and surprisingly, right, we actually caught COVID-19 patients, right? And they themselves, they did not know the existence of, they were actually suffering from COVID-19. So we actually, these are very, very active case, we call it active case detection, right? Active case detection. So this is an example of how location analytics can be very useful, not only in research, but in real life, in real world. We are actually doing life-saving work, right? This is something that we are actually doing. Until today, we are still doing, because we are also ensuring that the numbers will be as minimal as possible. Okay, so that is another case, is the TM point, right? That is under Telecom Malaysia. The use case is that Telecom Malaysia would like to know, right, whether or not they should expand their outlet to a new location. So that is where we also deploy this location analytics project to help them. So these are the two questions, right? Should I expand to this location? What retail business should I set up at this location? So this is the sample screen, sample system that we have provided, we have done, right? And as you can see, you have the green dot there, a green circle, you have red circle. The red circle says, don't bother, go to that location. Don't bother, don't waste time. The green color says, hey, you may want to consider. You may want to consider. Because Malaysia is big, but not as big as India, right? Even Malaysia, we have difficult going to entire Malaysia to study every single location. Would you be able to do that for the entire India? Yes, you could, but it will take long time, right? Very long time. So if we have a system that automate the entire thing, okay, we just put the system running in a cloud system where you have multiple virtual machine running. So you can scan the entire country maybe in 1 month time. Rather than we go down to the field, it may easily take us a few months, right? A few months, if not a year. So it's very, very taxing. So you can see here the green color. Why is it a green color? Because and so forth. These are so-called anchor. These are the top features that automatically extracted by feature selection algorithm. And this, the good thing is that this feature evolve across time. You know, business will you see businesses, the shops, you see them today, but there is no guarantee that you see them again in the next 6 months, right? So business changes. So these are some, and on the right hand side, you can see the projection of the sales and the comparison of the sales by given 3 locations. Even there are no outlets, we can actually simulate the sales. How do we do that? Basically, we can do that by uh, some similarity tests and also some prediction. But the key point here is you must have the analytical data set up first, right? The data set is a crucial point to do the rest of the thing, right? We can also here in our case here for a different any particular location, we actually can advise that okay, Nando's is a better choice as compared to McDonald's and Def Deli, right? So if you want to set up business here, these will be the ranking for your 3 options. So the user can key in as many options as they want. Okay, so this is the YouTube that if you want to see the demo of the program. Okay, so lastly, this is my information, right? I believe that the organizer has my contact, so you can get it from there as well. Okay, I think thank you very much for the time given to me. Yeah, thank you.
Thank you so much, sir.
Thank you.
Thank you so much, sir, for sharing your deep knowledge with us. So your session was full of enthusiasm and valuable knowledge, sir. So we have some questions from the participants, sir. I want to present the questions in the screen. So may I request you to kindly stop sharing your presentation, sir? Thank you, sir. Thank you. Just I want to share the questions, sir. So is it visible to you, sir?
Yes, I can see. I can see. Yes.
Yes, sir.
So for the first question, the answer is there is no difference. There is no difference. These are just the same terminology, different by different. These are the same terminologies used for location analytics, but they are used by different vendors, different companies. They are the same thing. Yes. For the second question, self-organization map, yes, you can try using that. Again, is whether the domain fits SOM or not. Then we have to be very careful on that. It is not about the technique. As I would like to emphasize again, it is not, we are not particularly interested in the technique, even though they are very important. But we are very particular on the structure of the analytical data set and the domain first. So what is the domain for and what domain are you solving? From there, we can identify what would be a good technique, right? We don't identify the technique and then we do the data crawling, the data aggregation, or the data preparation. No. In research, yes, we do that. But in practical world, we don't do that. We have to see the data first, then we identify the techniques. Okay? Is location analytics same as Google Analytics? No. Location analytics is totally different from Google Analytics. It's totally different. It has nothing to do with each other. Google Analytics is basically an analysis of the traffic, basically on traffic, right? In COVID-19 work, the Selangor state where I live in, we also use Google Analytics to study the pattern of movement, the usage, right? The usage, to monitor, to ensure that everybody is safe. So Google Analytics provide that information, right? So it is not location analytics. From region to region, the data varies by sentiment analysis. Then how to come with conclusion based? Okay, very good question. Very good question. We have a project with sentiment analytics on location as well. So you see, location analytics deals with more static data, while sentiment is dynamic. Sentiment is very, very dynamic, right? And for sentiment, what we do here is that we actually use sentiment data to fit into location analytic data. So in other words, sentiment module is externalized from the location analytic module. We don't mix them together. So the location analytics is nothing to do with the sentiment module. So sentiment is another module outside of location analytics module. For sentiment, we have tested a few methods from conventional natural language processing method from the linguistic approach, and we also use deep learning. We kind to find out that for Malaysia, right, for the data that we are using, deep learning is much better, right? Deep learning is much better in terms of their performance, right? Okay. Which are the suitable GIS data format? A good question also. We don't specify the whether you use Sharp, right? Whether you use other types of GIS data format. We don't do that. As long as we don't deal with that a lot. But why am I not dealing with that a lot? Because that is not our focus. Because the focus here is that we need to extract, we need to transform the data into a flat format. If you have a GIS data format, you have to externalize it, become a flat format like in Excel, in CSV, so that it is actually usable for machine learning. We do not need the polygons, right? The polygon has to be externalized in some format. Yes. I hope that I answer some of the questions here. Yeah. Can we do TensorFlow? Yes, of course. Of course, yes. You can. Definitely. We are using CNN, right? No problem. Right. But you have to configure again. You have to configure. We can use TensorFlow, you can use PyTorch, you can use Keras as well. Up to you, no issue. But we use them mainly for the image, not at the tabular data, right? The images. What are the challenges organization might have? The main challenges for me is, do you have enough location data or not? This is number one. You do have a lot of business data, but you may not have enough location data, because location data is very difficult to get and very, very expensive. For any organization, business data is easy to get because that is their business, right? No issue. But location data is difficult. Population data is difficult to get. So if in India, in your country, you can get those data easily, that is something that you should be very, very proud of your country, because that is something that is very hard to get in many, many countries. Okay, how are new location added? Oh, new location is just a new, in machine learning, it is just a new data fit into the model. So it is the same structure as the training data, right? If you're dealing with machine learning, you have the test and the train, right? the train and the test data. So the structure is the same as the test data. You need to transform everything before you fit into the model. Okay, so there is no difference in terms of the structure of data. Okay. What do you mean by publicly available without impacting the existing dataset being used? I'm not very not clear on this statement. What are the supposed to be used widely location? Okay, there are many location intelligence tools like you can go for S3 if you have heard of that, right? These are some of the quite commonly used. Again, they are the basis is still GIS, right? Geographical Information System. But no doubt that they do have some specific location intelligence module, right? Come with, of course, price. Then for that purpose, different vendor will have different module add on to the existing basic GIS module. Yeah. If you use the vendor, the commonly available from existing vendor, the good thing is that you don't spend time developing the front end, right? You don't spend time at all because you can directly use their front end, so that you have your Python program, you have your R program, sit at the back, and you can use their program to immediately consume your module. Again, number one is that you may not have full control on the interface. You may not have full control on the functionalities. You may not have the full control on the process flow. So you have to understand that, right? But if you want to develop everything from scratch, of course, time is a factor, right? Even whether or not you have money, right? You are financially good enough to have a team to develop the solution, but still you need time, right? So good and bad, good and bad. How the publicly available? The easiest way to do validation for location analytic work is not via machine learning approach. It's actually present the output to the end user and let them actually answer for you. If for McDonald's case, if I develop a system for them, what is the best validation way is that I am actually able to present to them location A is good, location B is bad, location C is good. Let them verify for themselves. If they say they agree with your finding, that is 100% accurate. Am I right? So they are the one who validate. So if you use machine learning way to do validation, this is just experiments only. It is not a real world validation. GPS is position. GIS is information. Right? So there are two different things. GIS is more on the map, but GPS is more on the location, the point. So it's different thing. GIS more than GPS. Yeah. Can you use the same specific cloud platform if you I do think that software or company or provider like Nokia, Google, they do provide both GIS and GPS, right? So these are the most of the provider, yes, like Nokia, like Nokia and Google, they do provide both GIS and GPS at the same time. Yes. Okay.
Okay. Thank you so much, sir.
Thank you.
Thank you so much for your nice explanation, sir. So we are looking forward for your support in our future events as well.
Oh, thank you. Thank you.
Sir, may I request you to like say a few words your what to say your department and your university about your university and your department. Just a few words, sir.
Oh, okay. Thank you. I'm attached to Multimedia University, located in Cyberjaya, Malaysia. Cyberjaya is a location where we have a lot of multinational companies like Dell, like HP, Shell, Experience, Prudential, and so forth. These are the IT companies that come into Malaysia, and they have a lot of well. If I am to tell you that we have a lot of Indian expats here, we have quite a number really Indian colleagues staying in Cyberjaya, and they are working in these multinational companies. So my faculty here I have been with the faculty for 19 years. All the while I'm teaching AI and machine learning. So we do have students from India as well. That is very common in many countries as well. Yeah. And I do appreciate the opportunity given to me for this sharing. Yeah. Thank you very much. Thank you.
Thank you, sir. Thank you once again.
Thank you.
Thank you, sir. Sir, namaskar.
Okay. Hello? Hello? What section? Sorry, I cannot hear. Okay. Sorry, the line here is a bit weak. Sorry.
Okay.
Yes, I can hear you. I can hear you.
Okay. So participants, now we can have a break for 5 minutes and we'll assemble after 5 minutes for the validatory function. Thank you so much. Thank you.
Thank you. Thank you.
Welcome, Puspa ma'am.
Good afternoon.
Shweta ma'am. Thank you. Honorable Director of MIT Silchar, Professor Sibaji Bandyopadhyay, Dr. Ting Shoi, Multimedia University, Malaysia, Dr. Samir Kumar Borgohain, Head, Department of Computer Science and Engineering of MIT Silchar, Dr. Sukumar Bhatti, Faculty Coordinator of MIT Silchar, all the deans, heads of various departments,
Hello, am I audible?
and their participants from India and abroad. On behalf of organizing committee, I, Dr. Malaya Dattabora, delighted to offer a gracious welcome to all of you to the valedictory function of 1 week online international faculty development program on machine learning and computer vision application research challenges MLCV 2020, organized by the Department of Computer Science and Engineering of MIT Silchar under TOMOGRAPHY as training activity with Guwahati University Institute of Science and Technology, Assam. Now, I would like to invite Dr. Naresh Babu M., organizer of MLCV 2020 and assistant professor of the Department of Computer Science and Engineering of MIT Silchar to present the report of MLCV 2020. Kindly, sir. Thank you, sir. Thank you. Now, I would like to invite one of the international participants, Venkateswaralu Sunkari, Assistant Professor, Addis Ababa Institute of Technology, Ethiopia, to provide the feedback of this activity. Kindly, sir.
Thank you, ma'am. Respected dignitaries, organizers, and my co-participants, good afternoon to one and all. I'm really thankful to organizers for giving me this opportunity to share my views on machine learning and computer vision 2020 organized by NIT Silchar and Guwahati University Institute of Science and Technology with you. I really enjoyed all 5 days. I participated all 5 days, all 11 technical and fruitful sessions delivered by eminent speakers from different universities and reputed institutions. Those sessions are very informative, and I learned a lot of things and acquired knowledge from innovative ideas from in the area of machine learning and computer vision, especially in health and medical areas. So once again, I would express my sincere thanks to all co-participants to raise many questions. That makes me to learn many things, many different things, because we did not get questions instantly. So I learned many things from the co-participants, also raised many questions, and very patient responses from the eminent speakers. So I'm very thankful to organizers to giving me this chance to share my views. Thanks one and all. Thank you so much.
Thank you, sir. Now I would like to invite Gopal Krishna, the scholar of NIT Silchar, Assam, to provide us the feedback. Gopal, kindly unmute your microphone.
Am I audible, ma'am?
Yes.
Good afternoon, respected directors, sirs, dean sirs, HOD sirs, all the professors, organizers, colleagues, and participants. I feel myself very much glad to attend this online faculty development program, MLCV 2020. Presentation by all the speakers was very knowledgeable and offered valuable information and tips. I learned a lot from this online faculty development program. These concepts and materials presented on machine learning, deep learning, neural network analysis will most definitely be incorporated into my resources. I found this online faculty development program really helpful. One of the most enjoyable and informative workshops I have ever attended. Thank you for organizing the programs and giving me an opportunity to attend this. And a very special thanks to the great speakers. Thank you.
Thank you, sir. Now I would like to invite Dr. B. Srinivas Raja, Assistant Professor, Adikabe Nannaya University from Andhra Pradesh, to provide us the feedback. Sir, kindly.
A very good afternoon to one and all. Am I audible, sir?
Yes.
Okay, ma'am. Okay, sir. Thank you, sir. First of all, I would like to thank all the organization of NIT Silchar who made this event more successful with your more informative sessions. I would like to extend my warm thanks to the entire team, because it's a lot of hard work that is going behind the screen. What we are observing in the virtual platform, we can visualize everything, but there's a lot of things which is going behind the screens. I thank all the organization. You're covered all the topics which are very novel to the research scholars nowadays. You have covered machine learning. Again, you have covered health informatics sessions, even deep learning, convolutional neural networks. Basically, I'm a doctorate in image processing and machine learning. So it took me a lot of new things which I have learned a lot, especially the resource persons. So they have covered elaborate topics. I really thank the organizations, because they are given prompt, they have done this in a more structural and professional way, because they took the feedback for every session Of course, they might be very strict, but this is the need of the hour, especially during this COVID pandemic situation. This is the time where we can learn more things in a professional way, and when we go back to our classrooms on virtual platform, we can deliver a lot to the students. So I thank once again to the NIT director and the entire department, the entire team who made a lot of effort in bringing more people, more resourceable information to the participants. Again, I congratulate all the participants because this is a good session for all of us because we have learned a lot and we have to do a lot, especially in research areas. I thank the entire resource person team because they took their valuable time to spend a quality time with us. So I thank all the people, especially the organizers, the team.
Thank you, sir. Thank you. Now I would like to invite Abhishek Bar, lecturer in EIE, Dr. Magnath Saha, Institute of Technology of Polytechnic Faculty of Bengal, to provide us the feedback. Sir, kindly.
Madam, am I audible?
Yes, yes, sir.
Okay. First of all, very good afternoon to all my esteemed colleagues, my senior teachers, and my friends, and also students. As I belong to electronics, it's a great privilege to be here to learn a lot of things regarding machine learning, the ML, DL, artificial intelligence, and other relevant research topics. These are the immense possibilities to enlighten our research thinking and revisions of our study and learning outcome based activities. So I would like to share my sincere thanks to the all presenters, all dignitaries of different institutes, especially the host and coordinator and entire organizing committee of NIT Silchar. Uh, and finally, in short, I can say that I would like to attend this kind of program in futures. And amid this pandemic situation, I would like to wish everybody to be blessed and stay safe. Thank you.
Thank you. Thank you, sir. Now I would like to invite Dr. Puspa, Associate Professor, Delhi Technical Campus, Greater Noida, to provide us the feedback. Madam, please.
Hello, ma'am. Am I audible?
Yes, yes, madam.
Oh, okay. So good afternoon to all dignitaries, organizers, and my co-participants. All the sessions were really very informative, knowledgeable, and well organized. This FDP has been a great success in all possible respects. Ma'am and sir, your organization was smooth and efficient throughout all the sessions. So thank you, NIT Silchar, to providing us a wide range of national and international speakers from challenging areas that discuss topics of machine learning, computer vision, deep learning, and specifically its relation with the healthcare, like segmentation of MRI images, Alzheimer disease, really offers a great benefit to me in order to solve my research problem and just design my research questions also. So once again, my heartfelt thanks to all the eminent speakers and all the organizing committee of NIT Silchar. Thank you so much, ma'am. Thank you.
Thank you. Thank you. Thank you, ma'am. Thank you so much. Now, I would like to invite Mohammad Qasim from Jamia Millia Islamia University, New Delhi, to provide us the feedback. So, please.
Hello, hello, ma'am.
Yes,
Ma'am,
yes.
am I audible, ma'am?
Audible, sir. Audible. Kindly.
Good afternoon to all the participants and faculty members to organize 1 week international faculty program for machine learning and computer vision. Ma'am, I am very grateful to Naresh sir and Malaya ma'am to organize this beautiful 5-day faculty program, and all the faculty speakers not only in India, only for abroad, and give me some valuable knowledge of different fields of AI like neural network or deep learning, and some case studies also. Actually, I am qualified net. I am looking forward to do PhD in artificial intelligence field, and after attending this 5-day faculty program, I have gained lots of knowledge and to improve, to think about what field in different for in AI field. So I am thankful to all the speakers, to speaker of NIT Silchar, DTU Delhi, Professor Jindal ma'am, and Dr. Peter Ho, Chewing to Sunway University from Malaysia, PK Das from IIT Guwahati, Guwahati Institute of Technology, Shri Jyoti Prakash Mehdi. All of the session are very good and very useful to me, and gain some knowledge and provide some useful information to start my PhD in AI field. Thanks a lot. Thanks a
Thank
lot
you.
to all the participants.
Yes, sir. Thank you, sir. Thank you. Thank you so much. Now
Thank
I
you,
would
ma'am.
like to invite Frederick Kamal Emerson V from Hungry Minds, Uttar Pradesh, to provide us the feedback. So kindly. So kindly unmute.
Thank you, ma'am. This 1-week online program on machine learning and computer vision research challenges had a great impact on me and also boosted my understanding of many concepts based on machine learning and computer vision. This program introduced me to a whole new world of ideas, challenges, and creativity which I am yet to deal with. Through these experts, I was able to grasp the concepts clearly while also enjoying the lecture. This lecture has made me familiar with many advanced topics like brainwave analysis, GPT-3, diabetic retinopathy, segmentation of MRI image, location analytics, and so on. Therefore, I am grateful to the NIT Silchar team for taking this program, and overall, this program is one of the best which I have ever attended. It's a unique way to teach students and also be heard of their questions. This program will remain as a dot in my life and come out in a future way, in an innovative way to serve the people of our country. I would like to conclude with the words of Steve Jobs. These dots will somehow connect you in the future. Thank you, everyone. Thank you, participants.
Thank you. Thank you so much. Now I would like to invite Dr. Sweta Taneza, Associate Professor of DMIT Delhi, to provide us the feedback. Madam, kindly.
Thank you, Dr. Malaya. Am I audible?
Yes, yes, madam. Yes, yes, please.
Good afternoon to everyone. This FDP was very well organized and informative. We have come to know about the intricacies of machine learning and deep learning, which will help us in our future research. I personally want to congratulate the organizers, especially Dr. Malaya Datta and Dr. Naresh Babu, for managing such a huge number of participants. That was really a record-breaking number, ma'am and sir, both of you. All the best for future. Thanks a lot, ma'am.
Thank you. Thank you so much, all the participants. Thank you for your valuable feedback. Thank you so much. Now, I would like to invite Dr. Sukumar Pati, Secretary Coordinator of NIT Silchar, to say a few words. So kindly.
Thank you, Dr. Boda. Good afternoon to one and all. Respected Director Sir, Professor B.K. Rai, Samir Kumar Vargaon, Head, Computer Science and Engineering, NIT Silchar, Professor C. Wang Ting, expert for this FDP, my esteemed colleagues and their participants. First of all, I must thank and congratulate to all the coordinators, Dr. Molaya Dottaboda, Dr. Naresh Babu M from NIT Silchar, and Dr. Porismita Sharma from GIST, Guwahati, for their initiative, planning, and tireless effort to conduct this online faculty development program. In the workshop. I do hope that you all have enjoyed all the technical sessions. As the feedback received from the participants, I really pleased with the FDP. As a coordinator Predictive 3, my responsibility is to analyze the outcomes of any program held under Predictive 3 As far as the outcomes of conducting this faculty development program is concerned, I am sure that all the participants have got valuable inputs after attending this faculty development program. I request you all to carry forward the knowledge and ideas that you have received from the lectures of distinguished experts and try to explore the possibility of future collaboration with the esteemed experts, both from NIT Silchar and other institutes. My request to coordinators of this workshop to issue e-certificate to all the participants as per TOMOGRAPhy norms. Once again, thank you to all the coordinators, distinguished experts, and participants for such a successful FDP. Thank you.
Thank you. Thank you, sir, for your inspired word. Thank you. Now, I would like to invite Dr. Tin Choyo from Multimedia University, Malaysia, to say a few words. So kindly.
Thank you, the chairman, the chairperson. Thank you very much for the invitation, and special thanks to Dr. Naresh as well for getting in touch with me and give me this great opportunity to learn from the rest. And this is my first time actually using online conference, online presentation as one of the speakers. But I do experience the motivation in this conference through the sharing of knowledge by other participants. Yeah, thank you very much for the opportunity again, and I do hope that we could collaborate in any matters, yeah, especially in R&D. Thank you very much. Thank you.
Thank you, sir. We are looking forward for your same support in our future event as well. Thank you so much, sir. Now, I would like to invite our Honorable Director of NIT Silchar and POSITRON MLCV 2020, Professor Sivaji Bandyopadhyay, sir, to provide the concluding remarks. Sir, kindly.
Yeah, very good afternoon to all the external distinguished speakers, my colleagues at NIT Silchar, the other participants, PhD students, who wanted to learn machine learning. So maybe many of you are working on this area, but as this is an era when with lot of data, so without machine learning techniques or algorithms, you cannot work on them. And with different application areas, the algorithms are different. So it was necessary for all of us to go deep into the issues. And that is one of the reasons. That is why such an faculty development program was basically planned. I was listening to the feedback by the different participants. So it looked good. That is, everyone is happy. Now, one say bit of sharing about machine learning is that say machine learning people sometimes use as basically as a tool. So without having any idea, that is how the algorithm basically works. And in many cases, that is when we were working as a say student. So SBM and CRF. So people are working on that area as the volume of the data grows. So people went for the neural network, deep neural network, and so on. Then came the transformer model, mainly for the sequence-to-sequence task. And there was an immense jump in the performance. And now during these 5 days of the workshop, I have seen that you have also gone through the BART model. And with the BART and the multilingual BART model, which normally are used in the sequence-to-sequence training and the learning. So there is a huge jump in the system performance. So with the pre-trained models and with the recent GPT-3 also. And I saw that there was deliberation on GPT-3 as well. But the main thing is that is why a particular model works better for a particular situation. So even in the international manuscripts that I review, so people seem to be do not have any idea about it. That is, people just apply the algorithm, get some better result, and then say that, okay, ours is better than the earlier ones. And if you look into the computer vision area, though this transformer model was developed for the text processing task of the sequence-to-sequence model, that is, say RNN model was actually used for a long time. Now in the computer vision area, the image processing, generally the convolutional network are used, but the transformer model, that is where the decoder level in the CNN, that is replaced by the transformer model. So people are also doing that, so that the real advantages of these pre-trained models that can be utilized also. So that is another way of looking into this machine learning model. That is, whatever has been beneficial in one scenario, how in your different scenario you can model it to that extent and take the advantage of that situation. I think all these issues, and obviously learning never stops. New and new algorithms will be coming up. The languages which are not in the BART model, obviously people will be working on that. More applications will be taking or giving good results out of it. And I wish that people who were in collaboration mode for the last 5 days, they will continue with their collaboration in future as well. So with this, I wish that the faculty development program was a grand success. Thank you.
Thank you, sir. Thank you for your kind words. Thank you so much, sir. This is the time for the truth of thanks. Gratitude is the fierce blossom which springs from the soul. At the outset, I would like to express my sincere gratitude to the Honorable Director of NIT Silchar, Professor Sibaji Bandyopadhyay, for giving his kind consent to organize this FDP. This event would not have been possible without his continuous supervision and motivation. Thank you, sir. I would like to acknowledge our sincere gratitude to the Honorable Director of GUIST, Professor Manav Deka, for giving his kind consent to organize this FDP as twinning activity and his kind presence in the inaugural function. I would like to express my gratitude to our speakers, Dr. Peter Wu Sayung Singh from Samui University, Malaysia, Dr. Tin Choi from Multimedia University, Malaysia, Dr. Professor P.K. Das from IIT Guwahati, Professor Nidal Sinha from NIT Silchar, Professor R.K. Agrawal from JNU Delhi, Professor Rajani Jindal from GTU Delhi, Dr. Vinit and Balasubramaniam from IIT Hyderabad, Dr. Pinky Roy from NIT Silchar, Dr. Sharush Kumar Biswas from NIT Silchar, Dr. Tripti Goel from NIT Silchar, and Sri Jyoti Prakash Medhi from GUIST Assam for their kind consent to be the speaker at MLCV 2020. This FDP has come to a very big height because of all your excellent talk in the field of machine learning and computer vision. I would also like to express my sincere thanks to the head of the department CSC, Dr. Samir Kumar Borgohain, faculty and other staff members of CSC department and other stakeholders of NIT Silchar for their direct and indirect support to organize this FDP. I want to extend sincere thanks to TechWeb 3 coordinator of NIT Silchar, Dr. Sukumar Pati, TechWeb 3 twinning activity coordinator of NIT Silchar, Dr. Bipul, TechWeb 3 coordinator of GUSD, Dr. Sankar Saikia, TechWeb 3 twinning activity coordinator of GUSD, Dr. Amitavo, for their support to organize the FDP. I would also like to thank Dr. Pranjit Bamansa, Associate Dean of Student Welfare, for kind support in publicity of this MLCV 2020 in eMedia. I would like to thank Barak Bulletin for their wonderful coverage of this event. I would like to offer my sincere thanks to all the participants from India and abroad for attending this session with patience and making your doubts clear by participating in question and answering session. I would like to extend my heartiest thanks to one of the coordinator, Dr. Naresh Babu M, for his kind consent and support and constant support starting from the idea of MLCV 2020 and to provide all the technical and other related support in every steps of MLCV 2020. Thank you so much, sir. Last but not the least, I offer vote of thanks to the co-coordinator, Dr. Parismita Soma from ZU YSP for cooperating me in the time of need. The end of a story is new beginning for many others. Let us have a hope, organize similar kind of events in near future. On this note, let's sign off from MLCV 2020. Have a nice day. Thank you. Namaskar to all. Namaskar. Thank you once again to all of you. Thank you.
Thank you.
Thank you, sir.
Thank you. Thank you.
Thank you so much, sir.
So thank you to
Thank you to all of you.
Thank you.
Thank you, sir. Thank you, Naresh, sir. Thank you very much.
I would like to thank all the participants for their cooperation. So support. Thank you.
Thank you, sir. Thank you.
Thank you, sir. Thank you, Naresh, sir. Thank you, Dr. Valentina, madam. Thank you very much.
Thank you, sir. Thank you, Naresh, sir. Thank you,
And Malaya Gupta madam.
Thank you, the entire
Thank you,
MIT
Naresh sir.
team.
Thank you, Malana ma'am. Thank you so much.
Thank you,
Thank
Malaya
you.
ma'am. Thank you, Naresh Babu sir.
Thank you all.
Thank you, the NIT director, sir, for giving us this opportunity to participate in this program, sir. Thank you very much.
Thank you. Thank you so much.
Thank you, sir. Thank you, ma'am.
Thank you, sir. Bye.
See you.
Thank you, sir. Thank you.
Okay, master. Bye.
Thank you, sir. Thank you. Thank you. Namaskar, sir. Okay. Now
So dear participants, the final feedback form will be shared by email. So thanks for your kind support. The certificates will be issued before 30th of this month. Within 2 days, we'll send you the certificates. Feedback link is already shared. Feedback for the session 11 is already shared. The final feedback will be sent by email. Certificate will be sent to you by email within 30th of this month. Thank you all. See you.